Stop, because this is recording.
Just in case, hang on.
Alright, answers to the short right. The first one, you needed to simplify by using the distributive property. To distribute, combine my terms, you would get 13x minus 14. For number 2, it asks, is this relation a function?
Yes.
Yes, this one is, because each of the x values only goes to one y value. If 19 went to 16 and 10, it would not be a function. Questions on either of those two?
No, ma'am.
Number 3, you needed to find the slope. So remember your y2 minus y1 over x2 minus x1. And then use that to find your slope. This one ended up simplifying to just 1. Questions on that one? Number 4, you needed to solve, distribute twice, combine your like terms, and then solve for x. And you should have gotten x equals negative 26. The last one, you needed to find the domain and range of both of this entire graph. So domain is the furthest point to the left, the furthest point to the right. Furthest point to the left is this line right here. It starts at 0 and then it keeps going to the right. So you can write it one of two ways. X is greater than or equal to 0 because it's included at that point. Or square bracket 0 to infinity. And then your y values, this keeps going down off the graph, and this keeps going up off the graph. So if it keeps going down and up, it's all real numbers. So this would be in set builder notation, y is an element of all real numbers, or all real numbers. And negative infinity to positive infinity, which means it goes on forever and ever in both directions. Questions on that one? Everyone should have notes on graphing linear inequalities. We're going to start that, or start and finish that today. As I mentioned before, the graphing aspect of this is similar to just graphing equations, but there are some differences as well. So first, we need to write the inequality in slope-intercept form. That's where it's the same. And that's if it's not already in slope-intercept form. So that part's the same as an equation. Then the next parts are actually for the inequality piece of it. We use a dashed line for less than, strictly less than, or strictly greater than symbols. And then we use a solid line for less than or equal to or greater than or equal to.
Oh, that says dash. I thought it said dashed line, and I read it, I was like, what?
I'll fix it. There we go. Dash.
Let's go. There you go.
So the solid line would be like a normal line that we draw. The dashed line is like the solid, but it's missing parts. And then because it's an inequality, like on the number line we usually draw arrows, Since it's on a graph, we are showing all of the solution area. So on a number line, if we say x is greater than 3, everything that is greater than 3 could be a solution. On a graph, we have to show all of the solutions that could work. So we shade in the area. So for less than or equal to, we shade below the line. And greater than or equal to, we shade above the line. So you'll need to know and remember those rules when we get into graphing. So we're going to do example 1. For example 1, it's already in slope-intercept form. So our first step, we can graph our y-intercept and our slope just like normal. So plot your y-intercept at -5. Then your slope is positive 1/3. So you're going to go up 1 to the right 3 as many times as possible from that point. I was missing a for a class. And then you can go down 1 to the left 3 as many times as possible from your y-intercept. This is a greater than symbol, so will this be a dashed or a solid line?
Solid. No dash. And it'd be up, right?
Shaded above, yeah. So this is going to be a dashed line, so you can either leave it like the dots and just draw arrows at the end, or you can add in little dashes in between dots. And then if this is greater than, like Josh said, this would be shaded above. Some of the lines are really easy to see which direction is above the line, which direction is below. But if you're not sure, look at your y-intercept, draw an arrow up and down. Up would be above, down would be below. Since we need above, I'm going to shade this area right here. You can shade it nicely, not nicely, it doesn't really matter. As long as you know that this area right here is the area you're shading. You can highlight it, you can draw lines, it doesn't matter.
Miss Lord, you know I can't do dash lines, so like I just do the whole line and then I erase parts of it.
Whatever works.
If you can't see it, say put some numbers in as well. You can put in -2. Would -2 be above the line or below the line? Or you can say -8. Just so you can, if you need to plot a point, that's one way that helps my learning, or I learn, is visualize it with points in this case. So just plot a couple just to show yourself, prove to yourself.
So before we move on to the next part, does anyone have questions, concerns, confusion on anything we just did?
Oh. What would be like A, B, C, D, E? Like
We're going to do that in a second. So now that we have this graph, the next part asks to determine which of the following points are solutions to the given inequality. So if these points fall in the shaded area, it's a solution. If they don't, they are not solutions. So the easiest way to see this is to plot these points and see, does it fall in the shaded area or not? So 0, 0, if I plotted that point, would that be a solution?
yeah. What if it's on the line?
We're going to test that in a second. 0, -5, that's the one that's on the line, so let's hold off on that one, we'll come back to it. 3, -2. Would that be a solution?
Yeah.
Yes. 5, -6.
No.
It is not in the shaded area, so that cannot be a solution. And then -7, 3.
Yeah.
Yes. So for 0, -5, because it falls on the line, could be a solution, could not be a solution, we're not sure. So the easiest way to check that one is to put this ordered pair back into the inequality. So I'm going to take the x and y value and put those in and see what happens. When I put that x and y value in, this just becomes 0. So I'm left with -5 is greater than -5. Is this a true statement?
No, it's equal to.
It's equal to, it's not greater than. So because it's not equal to, or the symbol is not equal to, this would not be a solution.
So, will we have questions where it is an equal sign and it is a solution?
Yes.
Okay.
So you can always
no.
you can always use this method for any of these points, whether you see it or not. But it's especially helpful for the ones that fall on the line. In general, though, if you have a dashed line or you have strictly greater than, strictly less than, and a point falls on that line, it would not be a solution. Yes, Josh?
So, let's say the -5 that's like pointed away from the alligator's mouth, so the one to the right, if it was supposed to be like, let's say -3, it still wouldn't be circled, right?
Just like, it was like this?
Yeah, because -3 is greater than -5, right?
Right. So if you did this and you got something that was false, it would not be a solution.
Okay.
If it was true, it would be a solution.
So, like, if the -2 was -7, it would be true.
Yes.
Got it. Look at me ask the question.
Do you have any other questions, concerns, confusion on that one? I'm going to do a few more. Step 2, the back. Now these inequalities are not in slope-intercept form. So we'll need to get them in slope-intercept form first and then graph them. So for number 5, we would solve this just like normals, get the x over to the other side by subtracting. We have -2y is greater than -5x plus 12. Divide everything by -2. What happens when we divide by the negative?
Hey,
You flip the sign. So this would become y is now less than +5 over 2x minus 6. So I could plot this inequality, start at my y-intercept of -6. My slope is 5 over 2, so I'm going to go up 5 and to the right 2 as many times as possible. Would this line be dashed or solid? Dashed, because it's strictly less than. And then would this be shaded above or below? Below, because it's less than. If you're not sure where below would be, draw your arrows. below would be where the arrow's pointing down. So that would be this area right here.
Oh, okay. So, will we ever have them where the line is like straight, vertical, or horizontally?
Yes.
Okay, so let's say this is vertical. How would you know which is up and which is down?
So pick a number.
What do you mean, like just two random numbers?
Pick one random
Oh,
number.
5.
5. So if x is greater than 5, give me a number that's greater than 5.
10.
Okay, so then it would be shaded in that direction,
Where the 10 is at?
where the 10 is at.
So
Going towards 10. From 5.
From 5 to 10.
Yeah.
Got it.
For your y, it's really easy to see above or below. Your x is kind of have to think about it like that. But we'll do a couple here in a bit. Give me one ordered pair that would be a solution. Anybody? Hello.
5, -2.
5, -2. 1, 2, 3, 4. That would be a solution.
1 and 1.
What did you say? 4, 1. Josh, you said 1, 1?
Yep.
Would that be a solution?
No.
Find a different one.
4 and -3.
4, -3 would be one. Anyone else want to see if their point would be a solution?
-3, -4. No, +3, -4.
+3, -4 would be a solution.
Would a -4 be one more down?
Yes. Okay. Did not have that correctly.
What y value would not work? What y value, no matter what x, would not work?
Anything that's negative?
Y value,
Y, oh, up and down, everything positive.
so what would
Stop
not work?
talking today.
What would not work?
Everything positive?
Look at the red dot. is.
So 7 wouldn't work.
Why would 7 not work?
It's a trick question. All values work. Any y value you put in, there's no y value that won't work. Every y value, it's the x values that are the problem. All y values will work. It's the x's that'll tell you whether you're
Okay.
shade or not.
Okay, so the way you're putting it is like, if we were to be on the x at positive, what is it, 6 or 7? Like all the way at the end, is it 7?
Yeah.
Okay, so you're saying that if we were all the way positive to 7, like what y's could we put there? Is that what you're trying to say?
Really it depends on both of them. So if it falls in the shaded area, it depends on what your line is. So like in this case, anything over here would not work. But I could have any of these x's and any of these y's that fall in the shaded area. Let's move on to the next one. We're going to do number 5. So with number 5, we again need to solve this. Subtract x on both sides. We have negative y is greater than or equal to negative x plus 8. Divide everything by a -1. So our new equation is y is now less than or equal to positive x minus 8. I don't know how well you can see that. Graph that like normal. Your y-intercept is going to be a little off of the graph because this is a 7 by 7. So you can put it like right there. Your slope is positive 1, so you can go up 1, right 1 as many times as possible. Would this be a dashed or a solid line? Solid. So when you make your line, connect all your dots. And would this be shaded above or below? Below. Here's a casting. So if you're not sure, you can draw your arrows. Below would be underneath. So this area right here. Someone give me a point that would be a solution to this. Josh, go ahead.
7, -7.
7, -7 would be a solution. 6, -5.
6, -6.
1, -8 would be a solution because it falls on the line. But we could also check that, put it in. What would happen is, yes, it is. Should be this one. But had we chose 0, -8, that would have also worked. We could put that in, and we would get -8 is less than or equal to -8, and that would make it a true statement. Josh, what was your other one?
I said -6. 6, -6.
Anyone else want to give a point that would be a solution? Now let's do number 7. With 7 and 8, you have to remember your products. So your horizontal lines have 0 slope and are y equals, or in this case, y inequalities. And then your vertical lines have undefined slope and are x equals, or x inequalities in this case. So for number 7, would this be a horizontal or vertical line? Horizontal. So this would be a y, it's going to be horizontal. So at -4, you can plot a point at that point. Would this be dashed or solid? Solid.
Solid.
So when we make our line, it's going to go all the way across at -4. And then with y inequalities, it's really easy to see above or below, because below has to be below this line. For your x's, those kind of go back to like your number line. If it's greater than, it's going to the right. If it's less than, it's going to the left. But for this one, what would be one point that would be a solution? You said 5, -5?
Yeah.
1, 2, 3, 4, 5. Yes. Anyone else want to give a point that would be a solution?
-5, -5.
Yes. For the next 10 or so minutes, I want you to go back and do the ones we did not do. So number 2, 4, 6, 8, all the evens. And then we'll go over this and then talk about the very last thing with graphing. Let us know if you have any questions or want something checked.
Kayla, where you at?
Okay.
You left all the way over there, Kayla?
Yes, bro.
That's how you doing?
As you guys are finishing them up, check your answers with mine.
Mine are obviously correct.
Number 2 should be a solid line shaded below with a slope of -2, -1. The following points were and were not solutions. 0, -1 was a solution because it fell on the line and this line is included. -4, 0 was a solution, but everything else was not. Questions on that one? Number 4, you needed to solve the inequality first. And you would got y is greater than 1/4 x minus 2. Graph that slope and y-intercept. You would have a dashed line shaded above. And you can pick any order pair that you want. It doesn't have to be mine, but 0, 0 would be a solution. Questions on that one?
Why do we have to find an order pair?
Just so that you know that anything in this shaded would be a solution. For number 6, you also needed to solve that one. Subtract your 3x to both sides and divide by 2. So y is less than -3/2x. So your y-intercept was 0, slope -3/2. You have a dashed line shaded below. And then you can pick any point in here. I just picked the point -2, 0. Yes.
How do you know when it's a solid dash?
Solid lines have the equal to in the inequalities. So like this one did, that's why it was solid. This one does not, so it's down. So if it has the
Okay.
equal to, it's solid. And then number 8 should have been a vertical line at 6. Everything greater than 6 would be going to the right. So there would be a thin area that's shaded. And the only solutions for this that would work is everything on 7. In reality, these graphs are like miniature graphs. These numbers really go on forever and ever. So I could really say that 7 -100 would be a solution. And it would, because on an actual graph that kept going, we could see that. On this 7 by 7 graph, we can't. But that would be a solution. Do we have any questions on how to graph linear inequalities? Rashad?
We go to number 4.
Number 4.
Oh, I just want to say both.
Right. There is one last piece we need to talk about with graphing inequalities. It's like the reverse of what we were just doing. So find the page that looks like this. Should be the next page. So now instead of graphing the inequalities, we're going to be given the graph and we have to write the inequality. So to do so, we would need to first identify what the slope and the y-intercept are. And then that will help us start to form our inequality. And then to actually determine what type of inequality it is, or what symbol we need to use, we need to look at whether it's a dashed or solid line, and whether it's shaded below or above. Right, so we're going to go through these kind of quickly, so make sure you're paying attention. We're going to start at number 1. So first we need to find our slope and our y-intercept. The y-intercept is usually easy to see. The slope is a little harder with dashed lines, not so much on solid lines. So we can say that our y-intercept here is 8. Because our line is not complete, or there's parts missing, you may think you know what the slope is, but then when you keep trying, maybe it doesn't work out, or maybe it does. It depends. So I would say, just like any other graph that we usually try and find the equation for, try to find a point that goes through the grid lines exactly. Because parts of the line are missing, you may have to guess this looks like it goes to the grid lines, or maybe you find one that actually does. So like at this dash, I see that this goes through these grid lines exactly. Pretty close. So if I count this slope, this would be down 4 to the right 2. I could simplify that to be -2. So if my slope is -2, that means down to right 1, I should get a point at every time I do that. So let's see if that works. From this point, I'm going to go down 2 to the right 1, and it looks like that falls on the line. I'm going to keep doing that and see if it goes all the way down. Down 2, right 1, down 2, right 1. And go up to left 1. And it looks like our slope follows our line. If it does follow your line all the way through, then that is your slope. If you start going and maybe your slope kind of goes off from your line, then that's probably not your slope. So now that we know our slope and know our y-intercept, we know this much so far. Y, there should be an inequality, -2, our variable x, and then +8. We know that much. What we don't know is the inequality symbol. So because this is a dashed line, we know it has to be less than or greater than. Strictly less than or strictly greater than. It has to be one of those. Then we need to determine which one it is. So you can either look and see, is this shaded above or below? If you're not sure, draw an arrow above and below your y-intercept. If the shading area is with the above arrow, it's shaded above. If the shading area is shaded with the below arrow, it's shaded below. So this one's above. So this would be greater than. So my inequality would be y is greater than -2x plus 8. Before we move forward, do you have any questions, concerns, confusion on how we got that? We're going to do a couple more. We're going to do number 2. For number 2, sorry, a few more. We can easily see what our y-intercept is. And then because it's a solid line, we can easily find what our slope would be because it crosses through all of these grid lines exactly. So we can say the slope of that is 1. So we know this much so far. Y, there's something missing. 1x minus 4. Because it's a solid line, it has to be less than or greater than or equal to. Less than or equal to or greater than or equal to is what it is. Has to be one of those two. We have to decide which one is it. Again, if you go to your y-intercept and draw your arrows, you'll be able to see which one it is. So this one matches the below. So this would be less than or equal to. So y is less than or equal to 1x minus 4 would be our answer for that one. So like I said earlier, it's easier for solid lines. Dashed lines, it's a little hard. Do we have any questions on either of those two? The last two we're going to do are horizontal and vertical lines. We're going to do numbers 5 and 6. Have a good rest of your day. The rest of the notes will be on Canvas. Okay. Thank you. For number 5, is this a horizontal or vertical line? Vertical. Vertical. So this would be an X. This is at 6. It has to be a strictly greater than or strictly less than. And this one, if I pick any of these numbers, is 10 greater than or less than 6? Greater. So this would be greater than. So then for 6, this is a horizontal, so we're going to use Y. This is at -9. It's a solid line, so it has to be one of the equal to's. Is this above or below? Shaded above or below? Below. So this would be less than or equal to. Do you have any questions, concerns, confusion on those two?
He wants to play with pencil and needs to be sharpened for number 5. I got a quick question. Here's the question. What is the y-intercept on number 5? What is the y-intercept on number 5? What is it? The y-intercept on number 5.
Say it again.
There isn't one.
It was a trick question. There is not one.
There's no y-intercept. Hell was on it.
You guys have, I'm going to give you the next 10 or so minutes to do the 4 we did not do, 3, 4, 7, and 8. And then I'll show the answers to that, and that'll be the last thing we do today. But you have this time to work with. Number 3 was y is greater than or equal to -3x plus 4. Number 4 was y is greater than 2x plus 1. Questions on either of those? Number 7 y is greater than 4. And number 8 was x is less than or equal to -2. So really quickly, upcoming assignments. 1, your compound and multi-step inequalities were due on Friday. You can still go back and do those. This coming Friday, as of right now, you have 3 on what we did today. 1 is on graphs of inequalities. 1 is on solutions to inequalities from a graph. So like it'll be graphed and you'll say, is this a solution or not? And then the third one is 2 variable inequalities from their graphs. That's like what we just did. Being able to write the inequality or match the inequality to its graph. So those 3 things are due on Friday. You have 1 Delta Math that's due next class. Next class, if we're here, we're gonna start our next and last lesson in inequalities. To mean that on Friday, if things don't get thrown off, we will have our quiz on inequalities, and then next Tuesday will be our test. If we have a snow day or something like that and that gets thrown off, then it'll just be same process or same timeline, but whatever day you next week. Right. Questions on any of those things? The very last thing, if you are still missing or need to take or finish Unit 2B, so it's parallel lines, linear regression, linear word problems test, or the Unit 3 test, the systems, and all of those, make sure you come see me today, tomorrow, Wednesday, or Thursday after school, or in the morning, to come get that done as soon as possible.